Welcome to Industrial Applications, Level 2. This is Working with Branches, Part 5, Branching Outputs. Okay, we've returned to our branching example, and we've focused so far on working with the left-hand rail or the input rail as opposed to the right-hand rail, which is the output rail. And I want to spend a bit of time looking at branching outputs because the behavior can be a little different, and it'll take some practice to make sure you put the branches where you want them to do what you want. Now I've took my output and I'm going to put my output back, and I'm going to start showing you what can happen with different scenarios. So let's say I have this logic. Whenever this is true, I want to turn on an internal coil, and I also want to turn on a pilot light. So I need to create a branch around here. So that seems to be pretty straightforward, except there's nowhere except way over here. That's the only place that's going to allow that branch anywhere close to that coil. So I got the wrong one. Let's go here. Same idea. Just pick the right one, dummy. Okay, no problem. Problem solved. Boom, it's done. Now this creates a dead short situation. The MicroLogix and the Connected Component Workbench software allows you to create dead shorts. You can have an empty rung, but it's a terrible habit to get into, and some processors, if you put that, you will fault the processor out. It's a major fault, and then you're scrambling to figure out what you did wrong. So making dead shorts on outputs or leaving a rung without an output is bad form. In the documentation that we have, there is a contact you can use as a placeholder called a NOP. It's under Program Control, and you can put that, and it's no longer considered to be a dead short. And all the NOP does is it's a placeholder. It performs no operation. It is a unique instruction because it can be an input and an output at the same time. So that's one way you can resolve your empty branch. Just as a placeholder, you're going to add stuff later, but we're not going to do that. We're going to actually put this to work. So if I want to make parallel outputs, I go back and I just grab another output, and again I can do the same thing. I can copy paste and then continue to stack up outputs. There are a number of reasons that you might want to do that, so let's do that for a moment. Control C, Control V. Why aren't you letting me copy and paste? That's interesting. Won't let me do it on an output. Did it on an input. Learning has occurred. Notice I tried to put it here and it leaped it over here. Working with the outputs on the output side can be frustrating. You can stick them in the middle and add them that way, or we can use our friend. Let's try our friend out, Control 8. That works really easy. And I can make these as much as I want. Now, once I've established this, let me get rid of my dummy branch, I can turn around and I can start adding preconditions ahead of each particular output. Once you completed that, there's all kinds of scenarios that you can do that will allow you to control individual outputs from basically one set of preconditions on the input, and it ends up becoming neater to look at in programming, but not necessarily faster in terms of processor speed. So I'm going to get rid of some of these. Okay, so now I've done that. Notice that the branch has disappeared. It's not what I wanted. I wanted to have a branch there, and I wanted to have another output. But now I want to have another branch condition here. Now if I place that on the wrong side, it doesn't do me any good, and you can start to try to drag stuff inside your branch. I would suggest that you take some time and just start building bizarre mazes just to watch what happens, because the software in the old days, what you used to be able to do was put a branch. I'm going to put one branch here. Then you could grab one side of it and you could branch out everything. But it doesn't behave that way anymore. So if I wanted to put a branch around all of this, I'd have to literally start by moving one contact and then putting another nested branch, then moving that into there, and now I want to move all of this, so I have to get rid of this branch, and I've got to take I think probably the best way here is to Control 8. No, that's not what I want, because that's going to put that in the wrong spot. So I'm going to take that side, delete that, Control 8 on the bottom. Okay, that looks better. Now I can drag that over, I can drag that over, I can drag. That takes care of that one, so I got to Control 8 again. And drag that one over, and then drag that one over, drag that over, drag that over, and now Control 8 one more time. Lose that, and now I've jumpered out all my work. Now if I want to move that over and add more contacts, I have to kind of put filler ones in until I get my instructions that I want. And you can see it can get more and more complicated. Again, do the next guy a favor, keep it simple, avoid nesting, and if you do have to nest around a particular one, put that closer to the bottom so that the most prevalent, easiest paths are easier to follow. Now we're going to show an example, one of the exercises of creating branches for outputs and particular applications for that. One thing that to keep in mind, that when you have physical real-world outputs and internal coils, that the last order wins. So avoid having outputs duplicated. Anytime you have a direct or reverse coil, make sure that you do not have it in multiple locations. You have plenty of opportunity to create branches whereby you have a whole bunch of conditions that may turn that particular output on, but you don't have it on in 4 or 5 different places in your program, because you'll have unusual behavior and it will not operate the way you're anticipating it.